So we are entering into a new unit where we're still going to be solving eventually, where we're going to want to get x equals, or those roots, or those zeros, or whatever phrase you hear. But before we get into the solving for this next part, we need to work a little bit on radicals or square roots. So here are some definitions for us. A square root, you guys know it's just the opposite of squaring. Okay, and that's what this says, just in more math terms, okay? A radical is the same word for square root. So when you hear the word radical, let me look for the marker. When you hear the word radical, it really just means square root, okay? Or a root. And I mean, it could be a cube root or a fourth root or anything like that. But that's just the name of that symbol, and that type of problem is a radical. And then a radicand is the number underneath there. So, so if the root is what's on the outside, then the radicand is this part right here. That's the radicand, is what's inside that root, okay? What's inside that radical. And then rationalizing, the word to be rational means to make a fraction out of it. And so that's the process of getting a radical, that root, out of the denominator and up into the numerator, so that it could actually be considered a fraction, because fractions, they can't be irrational in the denominator. So, so that's just us eliminating the root from the bottom and just making sure that if there's a root in a fraction, it's only on the top, okay? So those are the definitions here. We've got one more definition that I couldn't fit on here. So let's get that up here, and then we'll just actually start working out. All we're going to be doing this time is simplifying, meaning there's no solving. We're not going to be getting what x equals quite yet. We are just going to simplify. We've got to practice our roots in order for everything else in the unit to make sense. So that's why we're just practicing these radicals first. Alright, so the last definition, I want to make sure you can see it. The last definition is a conjugate. And the conjugate, I just kind of think of it as opposite. My students last year talked about how it looks like the word conjugate, like you do in Spanish. But it is the expression, or the expressions, yeah, we're talking about two of them. A plus the square root of b and a minus the square root of b. Used to rationalize the denominator whose product is always a rational number. Okay, so really, conjugates are the exact same thing, except one of them is adding and the other one is subtracting. Okay, so that when you multiply them, they cancel out the middle, so you don't have to deal with radicals or roots anymore. You'll see that when we go through and we multiply, the radical actually cancels out, and that's how we do that rationalizing, which is later on in the lesson. So, so conjugates are just the opposites. They're binomials with roots in them that are opposites. One's plus and one's a minus, okay? All right, so then here are some rules about radicals, about square roots that we have to practice, and that is, if you're multiplying two things in a radical, you can actually split them, excuse me, let me write that as A. You can actually split them up and square root them separately. So if we've got the square root of 18, we can split them up to the square root of 9 and the square root of 2, And that's helpful because the square root of 9 can square root. The square root of 9 is the number 3. Okay? So we can actually look at products, or these, I would call them factor pairs. 18, a factor pair is 9 and 2. So we can split the factor pairs so that if one of them roots, we can square root it, and the other one will just stay where it is, okay? Same type of rule for the quotient property. If you are square rooting an entire fraction, you can split the fraction up and square root them separately, because that might actually simplify more. So if you've got 2 25ths, if you split them, then the square root of 25 will square root itself, and we can just turn that into a 5. So we've got the square root of 2 on top, but now we just have a 5 on bottom. And in mentioning it briefly, that's a part of rationalizing. Since the whole thing was being square rooted, you need to get that root out of the bottom, but since the square root of 25 roots, then it worked out. So it's a root on the top, but that's fine, but no square root on the bottom, okay? So that is our product and our quotient properties. So we want to go ahead and practice those at the bottom of the page, so that as we build on this, we've got these this practice down. All right, so we want to go through the square root of 24. Well, you want to think of factor pairs, and the factor pairs that you want to think of are ones that have a perfect square. So if you go off to 24 and you list its factor pairs, 1 and 24 doesn't help. 2 and 12, neither one of those square roots. 3 and 8, neither one of those square roots. But 4 and 6, that is the pair that we care about because 4 will square root. So we want to split it up to the square root of 4 and the square root of 6. That's the factor pair, because what is the square root of 4? Well, that's just the number 2. So this one, let me use a different color. This one square roots, and that one didn't. So that one stays square root of 6, and that one square roots all the way, breaking it down all the way into a 2. Okay? All right, so then the next one, this is the color. Okay, the next one, the square root of 5 times the square root of 18. Well, we can work it backwards, and since they're both being square rooted, instead of separating them like we did here, we could actually multiply them together and get the square root of 90. Okay, all I did was I multiplied 5 times 18 because there is a perfect square in there. If you go off to the side and you say, okay, well, what are the factor pairs of 90? 1 and 90, 2 and 45, 5 and 18, which we just saw. There's probably more, but the one that's jumping out to me is 9 and 10, because 9 is a perfect square. It will square root. So if I separate that to the square root of 9 and the square root of 10, the square root of 9 is 3, and then square root of 10 just stays the way it is. So again, we put them together in order to get a better factor pair, because that square root of 9 that square root of 9 square roots into an actual number. And you want to simplify it as much as possible. You want to square root whatever you can. Okay? And then this last one, since 9 over 64 doesn't reduce, we want to go ahead and separate them to see if we can look at them separately. So we've got the square root of 9 and the square root of 64. Look at them separately, and that's pretty easy. You know the square root of 9 is just a 3, and you know that the square root of 64 is just an 8. So when you look at them separately, it's actually much easier to apply those roots, okay? All right, so then we've got to build on that. Let's see. Okay, we've got to build on that in order to bring in that rationalizing that we were talking about, okay?